Combining like terms falls under a very general skill that some people will call simplifying. Another skill that falls under that category of simplifying an algebraic expression is the distributive property. The distributive property is a method of simplifying an algebraic expression by distributing a value to each term in a set of parentheses through multiplication before combining like terms. So this is a step that we would do before we combine like terms. The distributive property is kind of like trick-or-treating. If you don't multiply each term in the set of parentheses by the variable, so if you don't give each kid candy, you're going to make a mistake, or in Halloween terms, you're going to get your house egged. We have a very general example here of distributive property, a times b plus c. So inside the parentheses, we have a binomial, b plus c. It needs to be multiplied, each term, by the a. So I'm going to distribute a to the b. A times b is ab. Distribute a to the c, to the second term. So I get positive a times c. So these are now equivalent algebraic expressions. They both represent the same value or same unknown. Let's use the distributive property to simplify some algebraic expressions. First, we need to multiply the value outside of the parentheses by each term inside the parentheses. So we have the algebraic expression 3 times 2 plus 4x plus 2x. So I need to distribute before I can combine like terms. I'm going to take 3 times 2. That's my first multiplication. I have two terms inside the parentheses, so I need to do multiplication 2 times. 3 times 2 is 6. I'm going to distribute the 3 to the 4x. 3 times 4x, I just multiply the coefficient. 3 times 4 is 12 sets of x. Next, I need to rewrite the algebraic expression, including all evaluated and non-evaluated terms. So I evaluated 6, because I got 3 times 2. I evaluated 12x because I did 3 times 4. I'm not doing anything to the 2x, so that needs to come down. The 2x remain the same, so it needs to remain the same in my new equivalent version of the algebraic expression. Now I can combine like terms if necessary. I see 6, I see 12x, and I see 2x. I do see common or like terms. 6 doesn't have any like terms, there's no other constants. 12x, however, does have a like term, 2x. 12x plus 2x gives me 14x. So I could write 6 plus 14x, or more traditionally it would be written 14x plus 6. Both mathematically are correct. However, on things like the ACT, you might see 14x plus 6 before you'd see 6 plus 14x. Let's look at a couple of exemptions to the rule. Now, the value that you are distributing doesn't always have to be to the left or in front of the set of parentheses. It can be to the right, as long as you know that that set of parentheses is being multiplied by a value. In this case, 8, you can distribute. So I'm going to multiply 8 times 2x to get 16x. 8 times positive 3 to get 24. Those don't combine, so there's my final answer. Now let's look at the next example. Here I have 2x minus 2 times 4x minus 5 plus 2x. So I'll be distributing negative 2 to 4x and negative 5. Be careful. If the term that you are distributing or the value that you're distributing has a negative sign or is being subtracted, assume that you are distributing a negative value. So I'm going to take negative 2 times positive 4x. Negative 2 times 4 is negative 8. Remember, just multiply the coefficients. Negative 2 times negative 5. Negative times negative gives me positive. So I'm going to bring down everything that was not evaluated. The 2x at the beginning and the 2x at the end just drop straight down. Now I can combine like terms. I see a couple sets of x, and I see a constant. 2 plus negative 8 plus positive 2, just add the coefficients up, gives me negative 4. So that gives me negative 4x. Plus 10 or positive 10 does not have another constant to combine with, so it's just plus 10. There's my final answer. On your own, try the last algebraic expression. Once we've fully simplified an algebraic expression, we can start to evaluate it. Evaluating requires us to use our order of operations skills. So let's review them real quick. We're not thinking about Dear Aunt Sally, we're thinking PEMDAS. P is the parentheses. Remember, this is any type of grouping symbol. E is our exponents. We're going to take care of all of our values in our parentheses using the order of operations inside the grouping symbol. Then we'll take care of all of our exponents. So that's anything 2 squared, -4 to the 3rd power, etc., etc. Multiplication and division, we always go from left to right. So left to right. It's not multiplication then division, it's multiplication division from left to right. Same thing with addition and subtraction. Addition and subtraction, you go again from left to right. Not addition then subtraction, you go left to right, following each operation as you see it. In order to evaluate an algebraic expression, we need to simplify and then use substitution. So I'm going to rewrite the problem, replacing all variables with sets of parentheses. So for example, I have 2x plus 3y plus 2. X and y I'm going to replace with parentheses. This way I know exactly where to substitute in the given values. In this case, they told me x equals 2 and y equals -4. I'm going to plug the given information into each set of parentheses. 2x is 2 times 2, so I'm going to plug the 2 in for the x. 3y is 3 times -4, so I'm going to plug the -4 in for the y. Next, I'm going to evaluate the expression using the order of operations. So now I've turned an algebraic expression that uses variables into an order of operations skill. Evaluating is about 90% an older skill, order of operations. So I'm going to go through from left to right. I only see multiplication first, so I don't see any parentheses to take care of, any exponents. So I'm going to do multiplication division from left to right. 2 times 2 is 4. I underline, I evaluate, I rewrite everything else. Next, I see 4 plus 3 times -4 plus 2. So 3 times -4 is my next set of multiplication. I underline, I evaluate, I rewrite. I only see addition subtraction, so I go from left to right. 4 minus 12, I underline. Remember, every time I underline, that's a calculator moment. 4 minus 12 in my calculator gives me -8. I underline, evaluate, rewrite. So I'm going to rewrite that to the value that was not changed or not evaluated. My last step, -8 plus 2, again, calculator moment. -8 plus 2 gives me -6 for a final answer. So 2x plus 3y plus 2, when x equals 2 and y equals -4, that simplifies down to -6. Let's try another example. In this case, you can choose to substitute directly into the variables as the expression's written, or you can distribute first. So I'm going to distribute that -4. -4 times x gives me -4x. -4 times -2y gives me +8y. I'm going to rewrite that +1. This to me is a little cleaner. Simplified expressions are a lot easier to substitute into. You don't have to do a bunch of extra substitution if all sets or all like terms have already been combined or distributed in this case. I'm going to rewrite the algebraic expression with parentheses. So -4 parentheses plus 8 parentheses plus 1. The x goes in the first set of parentheses, -3. So they told me x equals -3. They told me y equals 2. That's going to go in my second set. By putting the parentheses there, when I substitute my values in, I create an algebraic expression that can be evaluated using the order of operations. -3 times -4 gives me +12. I underline, evaluate, rewrite. So I'm going to bring down everything. +8 times 2 plus 1. The next operation in the order of operations, I see multiplication again. 8 times 2 gives me 16. So I'm going to underline, evaluate, rewrite. Remember, every time you underline, evaluate, rewrite, that's a calculator moment. 8 times 2 in my calculator gives me +16. I'm going to rewrite everything else down. The 12 didn't change. The +1 didn't change. I see only addition, so I'm going to go left to right. 12 plus 16 gives me 28. Underline, evaluate, rewrite, bring down that +1. Last operation, 28 plus 1 gives me 29. On your own, try the last problem.